Okay, let's look at the first one, that is androgenesis. The male gametophyte, that is the microspore or the immature pollen, it should produce the haploid plant. Okay. So the basic principle we have to do is we have to stop the development of pollen cell into the gamete. Okay. The sperm cells. Okay. Remember you had what to say, what is that? I forgot that fertilization chapter, no? From the pollen tube, you remember? You had the tube nucleus and then one more is there, no? You had the gamete and you had the tube nucleus. Something like that, no? Wasn't it? They were, we will revise, okay? You revise or you check when you do fertilization. So we want to stop this to form. We want the pollen nucleus. No, we want it to stay there. We don't want it to divide to form the what is that, generative cell and the sperm cell, something like that. No, and then remember that pollen tube used to form. No, then the generative cell will follow, and the male what is that, gamete cell also will go first. Something like that. I have forgotten. Okay, so we want to stop that development of the pollen into the gamete. Okay, so that because here the number of chromosomes is already n. Okay, so we want it to develop into a single plant. Okay, a plant which has only haploid number of chromosomes. So there are two approaches. We can do anther culture or pollen culture. Okay. And when we perform this experiment, it has to be optimal. Okay, all the temperature, the light, the humidity, all the environmental temperature should be perfect, should be suitable for androgenesis. Okay, looking at anther culture, then we select flower buds. Okay, so you took a young bud, a young flower. Why are we taking flower bud? Because we don't want a mature flower. Remember, a mature flower has already well developed pollens. No, we don't want. We are wanting a flower bud. Flower bud means the anther is very young. Okay, even the what to say, gynosium is very young. All the calyx are young, corolla are young, everything is young. So we want a young one. Okay. Where was I? Okay, so you take the flower buds, okay, of the young plants, and you surface sterilize them. Remember, I had told you it's a soap with sodium hypochlorite, no? NaO, Na. NaOH2 or something like that. I've forgotten the chemical composition, but sodium hypochlorite, it's like a chemical, but it behaves like a soap. Okay, but it's not a very harsh soap that will destroy the plant tissues. So okay, suppose you took in one. Oh my god, my okay, you've taken in one conical flask, then you added the flower bud. Okay, then you poured in the sodium hypochlorite and then you shake it. Okay, after shaking you rinse it, one time, 2 times, 3 times, 4 times, as many times to remove the soapiness with distilled water. So we have done the sterilization, surface sterilize, and then we will remove the anthers and their filaments. Okay, so just with a forceps, okay, you just pick up the anther with the filament. Okay, just with the forceps you take. Then we cut the anther under aseptic condition. Okay, aseptic means, remember girls, in the laminar airflow, which will be and then you when you're working on the laminar airflow, you have to wipe down. Okay, this is the laminar airflow working table. No, this is where the air comes in, and then everything is inside a hood. Okay, so you open just for us this much, and you keep your hands there. These are your hands. Such a good drawing, no? Then what you do? Oh, let me draw again. Let's say this is the working table, no? Okay, you are sitting here. Okay, this is covered inside a glass box. Okay, your fingers are there. Keep your fingers there. So the good air is coming from there, and then you wipe down the working table. Okay, the table that you're working on, you have to wipe down with alcohol. Then you wipe down your hands also with alcohol. You autoclave all of your forceps, your needle, your whatever, everything, your forceps, your needle, your petri plate, your agar, your whatever, except obviously the living tissue, no, except the flower bud. You surface sterilize the flower bud, but the rest you clean them very nice, so they should be in aseptic condition. Okay. Then you crush that anther which you cut in 1% acetocarmine to test the stage of pollen development. Okay, so we have done in practical, Miss will upload the videos, I guess, where you if you want to observe, I think you have done in zoo also, if you want to observe the stages of meiosis or mitosis, you remember, you boil it in acetocarmine, not boil, matlab heat, then you observe, you crush it and you observe in a microscope. So you have observed, because this acetocarmine has a stain, no? Then you can see at which stage, okay, the anthers are developed, okay, at mitosis 1 or meiosis 2, okay, at meiosis 1 or meiosis 2, at telophase or anaphase, okay. Telophase means you disregard, okay, you disregard it. So at mitosis phase, when the no, I think at telophase you take it because it has become N, no? So at telophase you can take, okay. At mitosis the pairing is still going on, but at prophase you don't take because it's still 2N, right? So when you have reached the correct stage with the anther, okay, not the boiled one, not the one that's already stained, means all these anthers will be in the same level. So you gently separate from the filament and then you inoculate them in a nutrient medium, okay. So this is your needle, let's say forceps, no? This is your anther, no, you have taken. Then this is the petri plate, you have poured in the agar here. This is the agar, no, it has become solidified. So simply you just put this with your forceps, no, you just put this anther there on the surface of the agar. Then you close the lid, okay, close the lid, and then we are done, okay. The injured anther should not be used as it will result in the damage of the anther wall tissues, okay. Then we have to keep in the alternating light and dark, those tube lights, which are automatic, because we cannot depend on nature, no, this is a very sensitive, okay. 12 to 8 hours, 18 hours of light and 6 to 12 hours of dark, and then at temperature of 28 degrees Celsius. Then the anthers, they will produce a lot of this anther, no, that you put on the nutrient medium, no, they'll produce lots of cells. Remember the cells is what? Is the callus, okay. And then that callus you take, okay, and then if you want it to form root, you take one callus and you add auxin. If you want it to form shoot, you take one callus and you add it cytokinin, okay, shoots, okay. Let's look at the diagram. So there, those are that's the flower bud, okay. Then those are the anthers. Then this one washing is going on, okay. Here they are extracting the pollen, okay. Then we culture the pollen, means you just add those pollen on that agar and then you grow it, okay. Then then the embryo will form, and those embryos will be haploid embryos, okay. If you treat colchicine also, Here this is like a shortcut. Okay, so here see the down part of the image, this one, down part of the image here, this one, this is like a shortcut. Instead of seeing in the microscope which one is at the right stage, no, directly you just take a plant, okay, a haploid plant or a diploid plant, and then you add colchicine, it's a chemical, directly half of the chromosomes, okay, from 2n, directly it will become n. You just add this colchicine, okay, directly becomes single n, and this n, whatever cell is there, you just grow it, directly you will get a haploid plant. So don't confuse, this is just like a shortcut. You know, this is using treatment method, this is using culture method.